This topic is converting between logarithmic and exponential equations. And basically you just have to have a rule of thumb written down. Just to give a little backfill, logarithms came about when we get the inverse of a function, we switch the x and the y. So when we have an exponential function, it's a way to get the exponent out of there. And that's it's a long story, much longer than this video will cover. I won't go into it, but that's where they come from. It's actually kind of cool. So anyways, what you need to know about this topic is if you have the log and it's in the base b, let's call it b for base, of x, that will equal a. So how do we say that? Log base b of x equals a. So what this becomes, and we can write it either way using these same exact letters that I have laid out, it's going to be rewritten as b, the base, raised to the a power would equal x. This doesn't come naturally to me, and I'm kind of a math person. So what I do is anytime I see I'm involved with logarithms, I write this down at the top of the paper just so that I can do it. And usually I actually put real numbers in. I will say something like this. I'll do that. I'll start with the fact that I know that this is a true statement. 2 times 2 times 2 is 8. So I remember that 2 is our base. So I write down the word log. 2 is our base, and it's of 8 equals 3. I always kind of just keep it in my head that it's 2 raised to this power here will give us this answer here. And again, like I said, it doesn't come naturally to me. So let us move forward and do a problem. So if you have this is an exponential equation, and they want you to convert it to logs, the way that we do it, of course, is we write down the word log. The base is 2, just like you learned when you had exponents, the base is 2. And it is the quantity of 1 that has to equal 0. And again, I kind of check in my head. 2 raised to 0 power does equal 1. Check. Perfect. Let's do another one like that. Let's say that we have 4 to the third equals 64. And they want us to convert it to logarithmic notation or a logarithmic equation. Again, just look at what they gave you as the exponent and figure out what the base is. The base is 4. So that's going to be my base down here. Log base 4 of what? Of 64 equals 3. And again, the way to check it is 4 to the third, 64. Yes, I've done that correctly. To go backwards from, say, a logarithmic equation and turn it into the exponential equation, it's going to follow a lot what we were just doing. And again, you can just verify if you did it correctly at the end. So if we're given this is a logarithmic equation. And again, all you have to kind of plant in your head, sorry, that's my dog in the background, is that it's the base, in this case 5, raised to the power equals 1 over 25. And you can kind of verify, is this true? Well, 5 to the negative 2, if I was going to recheck it, I have to sink that 5 into the denominator, and then my next step would be to square it, and that's exactly what I get. So I can kind of double check that that is true. Let's try one more. I just ran out of space here. Let's just say log base 3 of 27 equals 3. And again, this is a logarithmic equation. If they wanted us to convert it to exponential, it's always the base raised to the power. And is that true? Does 3 times 3 times 3 equal 27? Yep, it sure does. Kind of check it all by yourself, or all by itself. No, I feel like I